Imagine this, a shadow, vast and mysterious, lurking in the cosmos. But here's the twist, it only appears when no one's looking. Sounds like something out of a sci-fi movie, right? But it's real, and it's one of the most bizarre phenomena in the universe. This isn't just some fleeting glitch in the cosmos. It's a shadow that plays hide and seek with astronomers, and it's got scientists scratching their heads. If you've ever wondered about the mysteries of the universe, this is one story you won't want to miss. Stick around, because we're about to dive into the cosmic mystery that only reveals itself when we're not watching. Automated systems have long been employed in various fields to capture data and monitor environments when human presence is either impractical or impossible. In the context of the cosmic shadow phenomenon, these systems played a pivotal role in its initial detection. The shadow was first observed in footage recorded by automated cameras while the crew was asleep or occupied with other tasks. This circumstance raised intriguing questions about the nature of the shadow and its apparent sensitivity to human observation. The automated cameras in question were designed to capture high-resolution images and videos of the night sky. They were equipped with advanced sensors capable of detecting even the faintest light sources. The footage revealed a dark, amorphous shape that seemed to move independently of any known celestial bodies. What made this discovery particularly puzzling was the fact that the shadow only appeared when the cameras were operating without human oversight. Whenever crew members were present and actively monitoring the cameras, the shadow failed to materialize. Several hypotheses have been proposed to explain this peculiar behavior. One suggestion is that the presence of human observers might somehow influence the phenomenon, possibly through a yet unknown form of energy or consciousness. Another theory posits that the shadow could be a result of a technical glitch or an artifact of the camera's imaging process. However, extensive testing and calibration of the equipment have failed to replicate the shadow under controlled conditions, lending credence to the idea that it is a genuine, albeit elusive, cosmic event. The automated footage provided a wealth of data for analysis. Researchers meticulously examined the videos, frame by frame, to understand the shadow's characteristics and behavior. They noted that the shadow appeared to have a distinct, though irregular, shape and seemed to exhibit a degree of mobility. It would often drift across the field of view, sometimes disappearing and reappearing spontaneously. The lack of a discernible pattern or trigger for its appearance has made it difficult to predict or study the shadow under controlled conditions. This has left scientists with more questions than answers, fueling ongoing research and debate. The cosmic shadow, a phenomenon that manifests only when unobserved, presents a set of intriguing visual characteristics that have puzzled astronomers and physicists alike. One of the most striking features is its blurred edges. Unlike the sharp, well-defined boundaries of most celestial objects, this shadow appears to fade into the surrounding darkness, as if it's made of smoke or mist. This blurriness isn't uniform, either. It can vary greatly, sometimes appearing as a soft, diffused haze, other times as a jagged, uneven fringe. It's almost as if the shadow is constantly shifting, even when it's not moving. Inconsistent length is another baffling trait. The shadow doesn't maintain a steady size or shape. It can stretch out like a long, thin thread one moment, then contract into a small, dense blob the next. This inconsistency isn't random, though. There seems to be a pattern to the changes, a rhythm that scientists are still trying to decipher. It's like trying to solve a puzzle where the pieces keep changing shape. Position shifting between frames adds another layer of complexity. When observed through time-lapse photography or video, the shadow appears to jump from one place to another, defying the laws of motion as we understand them. It doesn't glide or drift, it just suddenly reappears elsewhere. This isn't a trick of the light or a flaw in the equipment. It's a genuine, albeit inexplicable, behavior. Some researchers have theorized that the shadow might exist in multiple places at once, only manifesting in one location at any given time. But this is still just a theory. The truth is, we don't know why it does this. It's one of the many mysteries that make this cosmic shadow so fascinating. In the vast expanse of space, there's a peculiar phenomenon that has baffled scientists and astronauts alike. This cosmic shadow, which appears under specific conditions, vanishes the moment it's observed or photographed. It's a stark reminder of how much we still don't understand about the universe. The observation paradox is a mind-bending concept. When cameras or astronauts focus on the shadow, it disappears instantly. It's as if the act of observation itself alters the phenomenon. This isn't just a quirk of light or a trick of the eye. It's a genuine, repeatable occurrence that challenges our understanding of physics. Scientists have tried to capture it on film, but the moment the shutter clicks, the shadow is gone. Astronauts have reported seeing it, but as soon as they turn their full attention to it, it vanishes. One might wonder if this is a problem with the equipment. But the shadow isn't just disappearing from cameras. It's also vanishing from direct human observation. This suggests that it's not an issue with technology. It's something deeper, something fundamental about the nature of observation itself. It's a bit like the quantum observer effect, where the act of measuring a particle can change its state, but on a much larger, more mysterious scale. To make matters more intriguing, the shadow doesn't seem to follow any predictable pattern. It appears in different locations and under different conditions. Sometimes it's a faint smudge on the edge of visibility. Other times, it's a stark, inky blackness that seems to absorb all light. But one thing remains constant. The moment you try to focus on it, it's gone. It's a cosmic game of peekaboo, and the universe always seems to be the one hiding. Motion detectors are designed to pick up on changes in their environment, like when something moves within their range. They work by sending out signals, like infrared or microwave pulses, and then measuring how those signals bounce back. If something moves, the signals change, and the detector triggers. But sometimes, even when there's clear movement, these detectors fail to respond. This inconsistency can be puzzling and frustrating. One reason for this might be the type of movement involved. Some detectors are tuned to pick up on specific kinds of motion. For example, they might be great at detecting quick, jerky movements but struggle with slow, smooth ones. Think of a slow-moving shadow creeping along a wall. It might not set off the detector, even though it's clearly moving. It's like trying to catch a slow-moving turtle with a net designed for fast-moving birds. The net might not work as well because the turtle moves too slowly. Another factor could be the sensitivity settings of the detector. If the sensitivity is set too low, it might ignore subtle movements. It's like having a volume control on a radio set too low. You might not hear soft sounds, even though they're there. Adjusting the sensitivity can help, but it's a balancing act. Set it too high, and you might get false alarms from things like flickering lights or passing shadows. Set it too low, and you might miss important movements. Environmental factors can also play a role. Things like bright lights, reflections, or even changes in temperature can interfere with how a motion detector works. For instance, a bright light might overwhelm the detector's sensors, making it harder for it to pick up on movements. Similarly, rapid temperature changes can cause false triggers or make the detector less sensitive. It's like trying to see clearly through a dirty window. The dirt can distort your view, making it hard to see what's really there. Understanding these factors can help in troubleshooting and improving the performance of motion detectors. The phenomenon of a cosmic shadow appearing only when no one is looking has baffled scientists and astronauts alike. The psychological strain on the crew is a significant aspect of this mystery. The repeated, unexplainable reappearances of the shadow have created a tense atmosphere among crew members. They feel a constant sense of unease, never knowing when the shadow might reappear. Living in close quarters with this uncertainty can be challenging. Crew members report feeling like they're constantly being watched, even when the shadow isn't visible. This has led to increased stress levels and sleep disturbances. Some crew members have even reported feeling paranoid, wondering if they're being observed when they're alone. The lack of understanding about the shadow's behavior only exacerbates these feelings. The crew's psychological strain is not just about fear of the unknown. It's also about the frustration of not being able to study the shadow when it appears. Scientists are eager to understand this phenomenon, but the shadow's elusive nature makes it difficult. This frustration can lead to tension among crew members, as they grapple with their inability to control or predict the shadow's appearances. The crew must rely on each other for support, but the constant stress can make this difficult. To cope with this strain, crew members have developed various strategies. Some turn to humor, using jokes to lighten the mood. Others find solace in shared activities, like games or movies, to distract themselves from their worries. Regular communication with Earth-based support teams also helps, providing a sense of connection and reassurance. Despite these efforts, the psychological strain remains a significant challenge for the crew. It's a testament to their resilience that they continue to function effectively under such unusual and stressful conditions. In the realm of quantum physics, the idea of an observer-dependent reality has long been a topic of fascination. One intriguing theoretical possibility is the existence of a quantum field that creates an optical phantom, visible only when no one is looking. This concept, often associated with the observer effect, suggests that the act of observation itself can influence the behavior of particles at a quantum level. At the heart of this idea is the notion that particles in a quantum state can exist in multiple places or states at once, a phenomenon known as superposition. When an observer measures or interacts with these particles, their state collapses into a definite position or condition. This raises the question, what happens when no one is observing? Some theories propose that particles might behave differently, potentially creating fleeting, phantom-like optical effects that vanish upon observation. Consider the double-slit experiment, a classic demonstration of quantum weirdness. When particles like electrons or photons are fired at a barrier with two slits, they create an interference pattern on a detector screen, as if they pass through both slits simultaneously. However, if you try to observe which slit each particle goes through, the interference pattern disappears, and the particles behave like solid objects. This suggests that the act of observation changes the outcome. Extending this idea, one could imagine a scenario where an optical phantom, a temporary, observer-dependent phenomenon, exists only when no one is looking, collapsing into nothingness the moment someone tries to observe it. This theoretical possibility is not just a philosophical musing. It has practical implications for fields like quantum computing and cryptography, where the delicate balance of quantum states is crucial. Understanding how observation affects quantum fields could lead to breakthroughs in technology and our fundamental understanding of reality. For instance, quantum computers rely on maintaining particles in a state of superposition to perform complex calculations. If an optical phantom or similar phenomenon were to interfere, it could disrupt these calculations. Conversely, harnessing such phenomena could lead to new ways of manipulating quantum states. Delving into old mission archives reveals intriguing parallels to the cosmic shadow phenomenon. In the 1960s, during the early days of space exploration, astronauts and mission control teams reported unusual shadow-like anomalies. These were often dismissed as optical illusions or equipment malfunctions. For instance, during the Gemini and Apollo missions, astronauts occasionally described seeing dark, amorphous shapes moving independently of any known celestial bodies. These reports were usually buried in mission transcripts, overshadowed by the excitement of other discoveries. Similar accounts surface in military aviation records from the mid-20th century. Pilots, particularly those involved in high-altitude or long-range flights, noted unexplained shadows that appeared on their instruments or outside their cockpits. These shadows didn't correspond to any known aircraft or weather phenomena. The lack of consistent patterns or explanations led to these incidents being filed away as anomalies, with little follow-up investigation. The common thread in these historical accounts is the transient nature of the shadows, much like the cosmic shadow observed in recent times. Another fascinating parallel comes from early satellite imagery. In the 1970s and 1980s, satellite operators occasionally captured images showing dark, irregular shapes that couldn't be attributed to any known objects or atmospheric conditions. These shadows appeared in different locations and under varying conditions, making them difficult to study systematically. The images were often declassified years later, sparking curiosity among researchers. The similarities between these historical anomalies and the current cosmic shadow suggest a long-standing, unexplained phenomenon that has evaded consistent documentation and analysis. The commonality across these historical accounts is the lack of conclusive evidence or explanations. The shadows were often dismissed as errors, illusions, or equipment malfunctions due to the limited technology and understanding of the time. However, the recurrence of these reports across different contexts, space missions, aviation, and satellite imagery, hints at a genuine, albeit elusive, phenomenon. This historical context provides a foundation for further investigation, encouraging a closer look at the cosmic shadow observed today. The archives offer a starting point, a reminder that unexplained phenomena have been noted before, and their study could shed light on the current mystery. The phenomenon of the cosmic shadow, which only appeared when unobserved, came to an abrupt end following a significant shift in its orbital path. This shift, likely caused by gravitational interactions with nearby celestial bodies, altered the shadow's trajectory and ultimately led to its disappearance. Scientists had long been baffled by the shadow's behavior, which seemed to defy conventional understanding of celestial mechanics. Its vanishing act only deepened the mystery. The orbit shift was not a sudden or dramatic event. Instead, it was a gradual process that went largely unnoticed until the shadow failed to appear as expected. This gradual change made it difficult for astronomers to pinpoint the exact moment when the shadow's behavior began to alter. The shift in orbit likely caused the shadow to move out of the specific alignment that allowed it to be visible under the peculiar conditions that defined its appearance. The cessation of the shadow's appearances left many questions unanswered. One of the most pressing was the nature of the shadow itself. Was it a previously unknown type of celestial object, or was it a phenomenon caused by some unusual interaction of light and matter? The lack of direct observation made it challenging to gather data that could shed light on these questions. Additionally, the shadow's behavior raised intriguing questions about the role of observation in the universe. Did the act of observing the shadow somehow influence its appearance, or was its behavior purely coincidental? Despite the unanswered questions, the event provided valuable insights into the complexities of celestial mechanics. It highlighted the need for continued observation and study of the cosmos. The shadow's disappearance also served as a reminder of the vastness and mystery of the universe. There are still many phenomena waiting to be discovered and understood. The cosmic shadow, whatever it was, remains a fascinating enigma, a fleeting glimpse into the unknown that continues to captivate the imagination of scientists and stargazers alike. All right, let's wrap this up. So, to sum it all up, we've been exploring this mind-bending phenomenon where a cosmic shadow appears only when no one's looking. It's like that old quantum physics thing where particles act differently when they're being observed, but on a much bigger, weirder scale. We've talked about the experiments that tried to capture it, the theories that might explain it, and why it's so damn hard to pin down. Now, first know what you might be thinking. This is all a bit out there, isn't it? And you're right, it is. But that's what makes it so fascinating. It's like the universe is playing a cosmic game of peekaboo with us, reminding us that there's still so much we don't understand. So, what can you do? Well, keep looking up at the night sky. Keep wondering, keep questioning. Maybe one day, you'll be the one to finally catch a glimpse of this elusive shadow. And who knows what other mysteries you might uncover. We've got more mind-blowing topics lined up for you. Next time, we are diving into the mystery of dark matter. What is it? Why can't we see it? And why does it make up most of the universe? Trust me, you won't want to miss it. So, hit that subscribe button, turn on notifications, and let's continue this journey of discovery together. Until next time, keep your eyes on the skies and your mind open to the mysteries of the universe.